read loop. We have integer, which is a number, sensor value, which is just a name I've given it, equals analog read sensor pin. So it's got sensor. There we go. Sensor pin. The function serial print sends information from the Ardino to a connected computer. You can see this information in your serial monitor. If you give serial print an argument in quotation marks, it will print out the text you typed. If you give it a variable as an argument, it will print out the value of that variable. Alrighty then. So serial dot print bracket, so it will write this out for me, sensor value, and a space, and finish it like that, and then it will write out this variable, which is an analog read sensor pin, sensor val. There we go. Ooh. Next one, convert sensor reading to voltage. With a little math, it's possible to figure out what the real voltage on the pin is. The voltage will be a value between 0 and 5 volts, and it will have a fractional part. For example, it might be 2.5 volts. So you'll need to store it inside a float. Create a variable named voltage to hold this number. Divide serial val by 1024.0 and multiply it by 5. The new number represents the voltage on the pin. Just like with the sensor value, you'll print this out to the serial monitor. So, creating a float value, voltage, oops, there we go, equals, sensor val divided by 1024.0 multiplied by 5.0. Now that you have the real temperature, okay, so first I need to write serial print print in, that must be the next one. So yeah, that's just, right, serial print, and then this will say voltage, comma, volts. There we go. Does not, there we go, volts. Then serial print voltage. So remember, the ones in the quote marks, speech marks, is what it will print exactly, and then just writing voltage by itself is printing the variable instead. Now that I have the real temperature, if you take, if you examine the sensor's datasheet, there is information about the range of the output voltage. Datasheets are like manuals for electronic components. They are written by engineers for other engineers. The datasheet for this sensor explains that every 10 millivolts of change from the sensor is equivalent to a temperature change of 1 degree Celsius. It also indicates that the sensor can read temperatures below 0 degrees. Because of this, you'll need to create an offset for values below freezing, 0 degrees. If you take the voltage, subtract 0.5, and multiply by 100, you get the accurate temperature in degrees Celsius. Store this new number in a floating point called temperature. So at the moment we've got a sensor value, and then a volts value, and now we can work out what its Celsius value is. Serial print. So maybe I'll do my float first, and then we can print it. Float temperature equals voltage, so I'm taking that data from before, minus 0.5 times by 100. And then I can print degrees C, and close all of that serial, print in is used, temperature, so it's serial print in. Now that you have the real temperature, print that out in the serial monitor too. Since the temperature variable is the last thing you're going to be printing out in this loop, you're going to use a slightly different command, serial print in. Is that an in or a serial print 1? Is that an L? Okay, L looks better. Yeah, because 1 hasn't come up with a orange text. ln. This command will create a new line in the serial monitor after it sends the value. Oh, serial print line maybe. This helps make things easier to read when they are being printed out. With the real temperature, you can set up an if-else statement to light the LEDs. Using the baseline temperature as a starting point, you'll turn on one LED on for every 2 degrees of temperature increase. That's above the baseline. You're going to be looking for a range of values as you move through the temperature scale. So the next set of code goes if temperature is less than baseline temp, open brackets, digital write to low. So 2 is the LED and low means off. Digital write 3 low and digital write 4 low. So I guess I could have created another for loop like we did up here, which just sets it all, but because we've only got 3 numbers, it's not going to take that long to do. Okay, so we've got the if, and now we need the else if. So if I just close that one, and then I can write else if. I need what I'm checking first, there we go. Else if temperature, I might just copy these because I'm not sure I've spelled them all the same way. Okay, that should be fine. Else if temperature is greater than or equal to baseline temp plus 2, and what does and means? The and operator means and in a logical sense. You can check for multiple conditions. If the temperature is 2 degrees greater than the baseline and it is less than 4 degrees above the baseline, that's what it's saying. So and temperature is less than baseline, nope, that's lowercase, baseline temp plus 4. Let's write that together actually. What do we want to happen when it's like this? We want to digital write just one of these to turn on. So I'm just going to copy that because I'm being lazy. And I want the first one to turn on. So this is changing that one to high. I'll close my brackets because that's the end of that. And I can do another else if statement. Else if. So we've got if it's less than temperature between these values, or if it's above these values. So we've covered all eventualities. What it could be. It's greater than or equal to baseline temp plus 6. And what do we want to happen? We want them all to be high. So I'm just going to copy that and change these ones. I'm missing one, aren't I? Else if baseline temp is greater than 2, else, hang on, between 2 and 4, no, this one, if temperature okay, there's one which looks like this one, because we want it to go, oh, that's not right, else if it's between, else if temperature is greater than baseline temp plus 2 and 4, and then it's between plus 4 and plus 6, and then if they're all on. Okay, let's just check I've got all these in the right place. You can do this by just clicking on them and it'll show you which one they're like partnered with. And then once I've done all of this, the analog to digital converter can only read so fast, so you should put a small delay at the very end of your loop. If you read from it too frequently, your values will appear erratic. So a delay of 1. With the code uploaded to Ardino, click the serial monitor icon. You should see a stream of values coming out formatted like this. Serial monitor icon. So this one. But it doesn't have a device attached, so that's fine. Right, I'm going to... Cool, testing the Ardino lover meter. So I've got my code and it's all ready to go. So first I need to plug this in and load in the code here, like so. And then if I go to the serial monitor, oh, it's still uploading. Okay, uploading done. Let's go to the serial monitor and let's see what's happening. So I've set my base temperature to 23 degrees, and for every 2 degrees a light will go on. So at the moment it is saying it is above it. So if it's above, 1 light goes on. If it's 25 degrees, 2 lights, and 26 will go 3 lights. But my hands are so cold, the temperature really isn't changing. But you can see that the code is working because it is receiving temperatures. And if I fiddle around over here and change the base temp, if I just do it as +1 and +2 and then greater than 2 and load this up. What's happening with our serial monitor at the moment? It's 23 degrees. Still 23 degrees. And it's 24 degrees, so it goes up 1. And 25 degrees, it goes up. And then if I take fingers off, it should cool down. Or it just stays like that. There we go.